All right, so now we're on to the notes for day 3, which was all about the unit 10, and unit 10 was all about the radicals. So the first thing we're going to focus in on is how to simplify the radicals. So we're going to put an example of simplifying up here to give us kind of a reminder about that. So let's just put in square root of 32. So we're going to try to simplify the square root of 32. Now, if I'm going to do that, the first thing I should check and see is if it's a perfect square. So they didn't give you this, so you're going to write this in at the top. First, check if perfect square by square root in calculator. Okay, because a lot of times we'll look at a problem, we'll think it's not a perfect square, and it is. So you should go and do the square root of 32. Well, since it's a decimal, it's not a perfect square. But something like 225, a lot of you wouldn't realize, but if I type in square root of 225, it does work, and it's 15. So make sure you always check that first. Also remember that I expect you to make a list. So let's write that at the top. Must make list of perfect squares. Whenever you're doing problems that involve perfect squares, I expect to see a list of perfect squares somewhere on the page, right? So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, then 144, and then you can keep going, but I think that's about as far as we need to go based on the numbers that I see on the page. Okay, so after we check to see if it's perfect square and we make our list, then we need to find the largest. Find the largest, and that is really important, right? Because you can find other perfect squares, but if it's not the biggest, it won't work. The largest perfect square that divides into the radical evenly. Into the radical evenly. So what I mean by that is this. I will tell you right now that 4 goes into 32, but it is not the largest perfect square, so you need to find the largest one, and the largest one ends up being 16. So this is really square root of 16, which goes in there twice, and that reduces to 4 square root of 2. Now don't take the square root again, because once we take the square root of the number, it comes out. And that's what part 2 is all about. We square root, we break the radicand into 2 numbers. Cross out the from. 1 is perfect square. Then you go ahead and you will not say pull out, you square root the perfect square. And multiply by any outside numbers. And multiply by any outside numbers. Okay? So we're going to do a couple examples of these together, and then I'm going to have you try 2 of them on your own. So right now, let's start out with number 3. If I'm looking at number 3, I need to find, actually, I think you'll be fine with that one. So I want you to, let's look at number 2 together, because I find that one to be tricky. Do you see right here how it says take the square root of a negative 8? Well, a lot of you will want to break that up right away into 4 and 2, but think about this. Does any number times itself give you a negative number? And the answer to that would be no. So we need to make ourselves a note. If negative in the radical, then no real solution. And this is a big one because you guys tend to forget this. So I would circle it and I would star it, because a lot of times we tend to forget that property. So this one you can't even simplify, so we'd say no real solution, or you could say cannot simplify. Either one is fine with me. All right, but now what I want you to do is I want you to pause the video and I want you to try 1, 3, and 4 on your own. So right now I want you to pause the video and try 1, 3, and 4 on your own. Okay, so you should have tried all of 3 of these on your own, and the first one should be the easiest, right? 81 is a perfect square. In fact, it's on our list of perfect squares. So the square root of 81 is 9, and that's your answer, and you're done. 48, we need to break up into 2 different perfect squares. So I would go through my list, and I would try all of them that are smaller. So I would try 36, and that wouldn't work. I'd try 25, and that doesn't work. I would try 16, and that does work. So that breaks up into 16, and 16 goes into it 3 times, which means this becomes 4. Square root 3 is your final answer. Again, don't take the square root again, because once you've taken it once, you're done with it. Okay? Looking at number 4. So again, 50 is not a perfect square, so we have to start trying. 49 would not work. 36 would not work. 25 does. 25 goes into 50 2 times. Now don't forget to bring down that -4 out front. Now we can go ahead and say, okay, well, we can square root the 25, which is 5, which makes it come out of the radical. There is no square root of 2, so we bring it down and bring down the -4. Now since there's nothing between these, we multiply them, and that becomes -20 square root of 2 as your final answer. All right, so now that we've finished simplifying, we're going to refocus and now on addition and subtraction. And remember, when we went over this the first time, I really emphasized that there's a difference between what you do when you're adding and subtracting and what you do when you're multiplying. So remember, with addition and subtraction, this is a big deal, right? I'd almost like put a whole bunch of stars at the end. This is a huge deal, right? When you are adding and subtracting, you must have same number in the radical. In other words, they must be like radicals. You can only add them if they're the same. If they're not the same, then you cannot add them. With multiplication, you multiply it no matter what. With addition and subtraction, they must have like radicals in order to add and subtract them. They must be alike. Okay, if they're not alike, then we need to deal with that by first, we simplify all the radicals. First, simplify all the radicals. Then once you have them simplified, if the radicands are the same, then you add or subtract the coefficients. But remember, number in radical stays the same. The number in the radical stays the same. And again, that's another huge deal, right? When we're adding and subtracting, we are combining like radicals, which means the radical stays the same and the only thing that changes is the coefficient. So let's go down to number 5 and do a problem that's just like that, dealing with addition and subtraction. So right now I see addition and subtraction, but these numbers are not like radicals. So since they're not alike, we need to simplify them first. So we would go back up to our list of perfect squares and find the biggest perfect square that goes into 150 evenly. So we do 150 divided by 144. That doesn't work. 150 divided by 121. That doesn't work. Keep going until you find one that works. So go ahead and do that now. Type it in your calculator, find the largest perfect square that works. Okay, hopefully one of you have found it, but it was not 81, it was not 64, it wasn't 49, it wasn't 36, but it was 25. And 25 goes into 150 6 times. So then we can go ahead and continue simplifying this. Which one can we take the square root of? Well, we can take the square root of 25, and the square root of 25 is 5. We cannot square root the 6, so we leave it a 6, and then we bring down our plus sign. Then we go ahead and we do the same thing for the other one. So we have to find the biggest perfect square that goes into 54. So the first one that we try is 49. 54 divided by 49 does not work. Then you should be trying 36. And 36 doesn't work. And then you should try 25. 25 doesn't work. And then you should try 16. 16 doesn't work. So then we would try 9, right? Go through the list. 9 works, and 9 goes in there 6 times. Now don't forget there's also a number out front that we need to bring down. Now we can square root the 9 to get 3. So we have 2, 3, and then we can't square root 6. Remember that there's multiplication between these, so really we end up with 6 square root 6. Bring down the other pieces. Now when I look at these, the numbers in the radical are the same, so they're like radicals, so we add them together to get, remember, we only add our coefficients, so 5 plus 6 is 11, and then we keep the number in the radical the same, because this is saying we have 11 of the square roots of 6. So remember, adding and subtracting, we have to simplify to create like radicals, and then we add the coefficients, but leave the radicals the same. So now what you're going to do is you're going to go ahead, you're going to try number 6, 7, and 8 on your own. So go ahead and pause the video, remembering that as you work, if you need to, you may ask the person sitting in front of you or behind you for help, but you are not getting up and wandering around, and that you should be trying all of them, and then once everyone's done, unpause the video to watch the explanation. All right, so obviously these are not like radicals, which means we need to simplify them. So we have to find the biggest perfect square that goes into 98, and that would be 49. So 49 goes into 98 twice. The square root of 49 is 7, square root of 2, bring down our minus sign. Then we need to find the largest perfect square that goes into 72, and that would be 36 goes into it twice, and don't forget to bring down the 3 out front. So now we have 3 times the square root of 36, which is 6, square root of 2, which is 18 square root of 2. So now we have 7 square root of 2 minus 18 square root of 2, which would give you negative 11 square roots of 2. Okay, so let's take a minute and look at number 7. Now number 7 took a few more steps because there's a few more to break up. So the biggest perfect square that goes into 32 is 16. 16 goes into 32 twice, but don't forget to bring the outside number down. Now we can keep simplifying. 16 is a perfect square. The square root of 16 is 4. Again, this is now out of the square root because 4 times 4 is 16. We do not square root it again. Bring down the square root of 2, bring down the 2. If there are 2 numbers out front, that means there's multiplication between them, so this simplifies to 8 square root of 2. Bring down your plus sign. Now we can work on the middle one, so we need to find the biggest perfect square that goes into 27, and that would be 9. 9 goes into 27 3 times. And then we still have our 3 out front. The square root of 9 is 3. We still have our 3 out front and a square root of 3. The outside numbers get multiplied, giving us 9 square root of 3. Bring down your minus sign. Then we need to split up the last one. So the largest perfect square that goes into 75 is 25, and it goes in there 3 times. Square root of 25 is 5. We can't square root 3. There's nothing to multiply it by, so we just bring that down. Now we need to look and see if there are any like terms. Well, this time there are like terms, but not all of them are like terms. The only like terms we have here are the square roots of 3 ones. So those are the only ones we're going to combine. So 9 minus 5 would give me positive 4 square root of 3, and then we bring down our 8 square root of 2. And that's your final answer. Because they're not like terms, we can't combine them, so you end up with 2 at the end. All right, so now number 8, hopefully was a pretty quick one for you. Remember, you always must check to see if they're perfect squares first. Well, 121 is a perfect square. The square root of 121 is 11. Bring down my minus sign. 9 is a perfect square. The square root of 9 is 3. Bring down the plus sign. 36 is a perfect square. The square root of 36 is 6. And now, these are like terms because none of them have radicals, so we do 11 minus 3, which is 8 plus 6 would give me 14 as my final answer. Now you'll continue on to the second video for the last page worth of notes.